Welcome everyone. Today we will learn the drawing of geological profile and cross section of this particular map. This is map number 3. So before drawing the cross section and profile, let's first interpret this map. So as we can see that the contour values are ranging from 400 feet up to 800 feet. So we can easily interpret relief of this particular area. The relief of this area is varying between more than 300 feet to less than 900 feet elevation. The minimum relief of this particular area is more than 300 feet but less than 400 feet, and maximum relief of this particular area is more than 800 feet but less than 900 feet. As we can deduce from the shape of contours that this area is characterized by presence of some hills, and V shape indicates the presence of valleys in this particular region. So if any of the drainage occurs, the occurrence of drainage is in this particular V-shaped valleys. So here we have this hill. Because center contour is having more value than the surrounding one, it means this is a hill somewhat of this shape. Then we have again hill over here, and this is the area where the valleys are there. Another thing we need to know, apart from topography, we need to know the structure of the area. So let's try to know that what are the structures present in this particular area. So we can see 1 trace, 2 trace and 3 trace over here. But stop, if we see that 1 trace is being repeated or 2 lithologies is repeated at 2 different places. So this lithology is over here and this lithology is over here. It means 1 trace is being repeated again, so there are only 2 traces. It means there are 2 beds in this particular area. So there are 2 traces, it means there are 2 plus 1 equals to 3 beds. 1 bed is being repeated at some place here. So this is the lithology which we are getting over here and over here again. It means that this particular lithology is either overlying this lithology or underlying this lithology, and it is exposed because of erosion. So now we know that there are 3 beds in this particular region. Now let's try to know what is the nature of the beds. So if we see that contour lines are intersecting to one particular trace, and more than one value of contour line are intersecting to one particular trace. For example, if we see this particular trace, so here 600 is intersecting this particular value of trace, and the 500 is intersecting over here, and here the 400 is intersecting to the same trace. 500 is again intersecting over here. Here the 600, 700, 800, it means this particular trace, one single trace is intersected at different places by different values of contour lines. But contour lines lie at one particular single height. One particular value of contour line lies at one height. It means that this particular trace is lying at different heights. That simply means that these beds are dipping rather than being horizontal. So here we have 3 beds which are simply dipping. Now let's try to find out the strike direction and dip direction. But before that, let's try to interpret the edges of these particular beds. So in order to interpret, we will have to first know the dip direction, because as a rule that in the direction of dip, the younger beds are going to occur. So in order to determine the dip direction, first we'll have to determine the strike direction, and dip direction is perpendicular to the strike direction from higher value of a strike to lower value of a strike. So a strike can be easily drawn by drawing a line from 2 points of the bedding plane which is intersected by same value of contour. So if we take these 2 points, so it is intersected by 700, and here the same trace is intersected by 700. We can choose any of the trace depending upon our will. So let's draw this particular strike line. So here the value of this strike line is 700 because this trace at 2 places is intersected by the value of 700 contour. Again, in order to determine the direction of dip, we need one more strike line, because we need successive higher or lower value of a strike line, so we can define the direction of dip. So let's see that whether this particular trace is being intersected by any other value of contour line or not. So we can see here 800 is intersecting this trace at 2 places. So we need now only one point, and we will draw a line passing through this particular point parallel to the previous strike line. So we will have to always make parallel lines with the help of set squares. So if you have got good guesses, you can draw it by looking at different distances. So if we are drawing from here, this is another value of strike line. So if this was 700, this is 800. So now we know that the dip direction is from higher value of a strike line to lower value of a strike line. It means this is the direction of dip. This is north direction. If the north is not mentioned, the top of map is always north. So if this is north, this will be the east direction and this is the west direction. So a strike of this particular bed is north-south and dip is towards east. So beds are easterly dipping. Now we have determined the dip direction of the bed. So now we can determine the ages of these beds. In fact, the relative ages of these beds. Since in the direction of dip, younger beds occur, so opposite direction to the dip, the oldest bed will occur. So this is going to be the bed number 1. Now bed number 2. If we move in the direction of dip, so we are getting the bed number 2 over here, and we are again getting the bed number 2 over here. This is the repetition of bed number 2. Here the bed number 2 is overlying the bed number 1, and here it has been eroded, so the bed number 1 is exposed in these regions. This is the oldest bed. Then we have got the bed number 2, and here we have bed number 3. We already knew from the number of traces, because there are 2 traces which are not repeating, so we have 3 beds. Now we have determined the direction of dip and we have determined the younging directions. So now we can interpret the geological history. The bed number 1 must have been deposited unconfirmably over an unknown basement. This unconfirmable deposition of bed number 1 was followed by a confirmable deposition of bed number 2 and 3. Then the area must have been uplifted or tilted during or after the upliftment, and the area must have been eroded to form the present day topography. Now let's draw the profile and the cross section. For that we need one another page which should be blank. We need pencil, set square. So either we can make some strip and draw the map, or we can fold this map. So we are going to place a paper on which we have to draw the map, and we are going to take this particular map and fold this map in the direction in which we have to prepare the cross section. So fold the map from XY points. So this is X and this is Y. Now put this particular map and draw a baseline. So for drawing baseline, simply mark the points X and Y. So here is X and here is point Y. So we have got the length of baseline. Now we need to mark the value of contour lines, and we need also to mark the bedding traces. So I am marking here by red point the bedding traces, and I'm going to use some another color for the contour lines. So here are the contour lines. Now we need to write down the values of contour lines so that we do not forget while drawing the profile and cross section. So this was 800, this is again 800, this is 700, this is 600, this is back again, we have 600, and this is 600, this is 500, so this would be 500, and this again is 500. Now let's draw the baseline. So this is our baseline. Now we need to draw the profile, for which we will have to draw the heights so that we can project the contours and get the shape of profile. So our contour values are varied from 400 to 800. So if we draw up to 1000, that will be sufficient for us. So because this scale is 10 division scale, so 0.1 inch scale is going to represent 100 feet, as the map scale is 1 inch is equal to 1000 feet. So mark these values. This is 0. I'm going to mark alternate. This will be 200, will be 400, this will be 600, 800 and 1000. Similarly, we'll mark in this direction as well. So mark these values of 0.1 division. And now we'll have to write this is 0 feet. So we have marked alternate even values over here. So I'm marking the odd values over here. This is 100, this is 200, and this is 300, this is 400, this is 500, this is 600, this is 700, 800, and this is 900, and this is 1000. Now let's project these contour values so that we can get profile. This is 800, just perpendicular to this baseline, project this particular 800 value. So we can either go like this so that we can put these points over here at 800 and here again at 800 and mark just above. Or we can simply put this and mark perpendicular to this value. We will have to take one thing in care, that we are going to use a 10 division scale while doing this exercise. So this is 800 back again, mark 800 over here. Then we have 700, mark the value of 700. This is 600, mark the value of 600. This is 500, mark the value of 500. This is 500 back again, 500. This is 600, this is 600. This is back again 600, and this is 500. Now we are done with the marking of values of these contours. So before we draw the profile, let's first determine the amount of dip. For that, we can measure this value. This is HE. This is taken in cross-section direction. So we already have learned with the help of HE and CI, we can determine the value of dip or amount of dip. So if this is HE, either we can mark this value and draw somewhere else, or we can simply put HE perpendicular to the CI or CI perpendicular to HE. So I'm going to do this exercise over here only. So I'm going to mark CI in this direction. So since this is 0.1 inch, CI for a particular map is always constant. And now join these 2 points. As the HE increases, the theta value decreases. And as HE decreases, the theta value, that is dip, increases. So now we can measure this particular angle with the help of protractor. This measurement should be precise. So the value of dip is 6 degree. So theta is 6 degree. Now we will draw this profile by joining different contour values which we have already plotted. So here we can see that the value is 800 and back again we must have got 700 in continuation. So this point 800, and here you will have to start in between the 800 and 700. What like this. Then we will have to join another points smoothly. Now let's see what is the trend in this particular direction. So this is 500, this is 600, and this is 400. It means the next will come 400. So this is 500, we will have to join in between 500 and 400 somewhere. So this is how the topography is varying from X to Y. This is point X and this is Y. At the baseline, this is actually the point X and this is point Y. So if you start walking from X to Y, you are going to get these type of relief variations. Now let's project the beds onto the profile. So we have marked the points where bedding planes are by red line. Here, one is here, one is here, and one is here. And we have already determined the amount of dip. Amount of dip is 6 degree and direction is towards the east, that is from x to y. So we will have to draw that value over the baseline, so we can take parallel line to that value and draw our beds. So let's mark any point. So for reference, I'm going to use this point, and let's draw the 6 degree value. So now this is theta value. Now we'll have to draw the beds parallel to this particular line. So for doing that, we have different set squares. So from here, and one more line parallel to this particular line, because trace is present over here as well. So we have drawn one line from this point parallel to this line, one line from this point, as this particular profile is coming below these points. It means the older bed is exposed over here. We'll have to make it somewhat darker. So now we have prepared our cross section. Now we need to fill the symbols in this particular map. So as we can see that bed number 3 has got this symbol, bed number 1 has got this symbol. So 1 is represented by this particular symbol. Have to fill over here. Then bed number 2 is represented by this color of symbol. So this is bed number 2. Bed 2 is eroded, so bed 1 is again exposed in this particular area. We can see the bed number 2 from here to here, and here from here to here on our profile and cross section as well. So here we have again exposure of bed number 1, and we are getting the exposure of bed number 1 from here to here. Then again we are getting bed number 2. and bed number 2 in the ground is going like this. And now bed number 3 is above the bed number 2, and it is represented by this type of symbol. So bed number 1 is shale bed, and bed number 2 is limestone bed, which is exposed over here, and continuation is over here. And this particular point, this particular trace is exposed, and then we are getting the bed number 3 from here to here. Now we can analyze this map by this particular section over here. So if we start walking from X, we first get bed number 1. We are getting bed number 1 up to here, and then we are getting the bed number 2 from this point to this point. So we are getting the bed number 2. Then we are again getting bed number 1 because of erosion of bed number 2. So we are again getting bed number 1 in this region. Then we are again getting bed number 2. So here, from here to here, we are getting bed number 2. And then we are getting bed number 3 up to Y. So we are getting bed number 3. So now we have completed our this particular map. We have already drawn the profile and cross section. So we'll have to mention it. This is geological cross section along XY line. Right. Now we can make index and fill the symbol. So this we will be doing while interpreting this map. So let's interpret this map. So we interpret the map in 4 different points. So what are those points? The very first point is topography. So as we can see in this map, the relief is varying between 400 and 800. The lowest value is 400 and highest value is 800. It means the lowest relief is more than 300 feet and less than 400 feet, and highest relief is more than 800 feet but less than 900 feet. Then second point is structures present. So what are the structures? We have 3 simple dipping beds. Now third point we do is order of superposition. For that, what we do? We actually draw the lithological cross section in undeformed manner. So we have 3 beds. At the bottom we have shale, above the shale we have limestone, which is represented by this symbol, and above the limestone we have grit, which is represented by these symbols. So this is order of superposition after balancing the cross section, because this bed is deformed, but whenever we find the order of superposition, we undeformed that particular sequence and find when it was formed originally. So at the bottom we have unconformable basement over which the shale was deposited. Then there was conformable deposition of this limestone and grit. Now the fourth point we do is to interpret the geological history. So as we can see from the order of superposition, the bed number 1, that is shale, must have been deposited over unknown basement. This was followed by the conformable deposition of limestone and grit. So there must have been deposition somewhat like this. So this have been some basin in which the shale was deposited. Then the shale is represented by this type of symbol. Then we have deposition of limestone, and ultimately we have deposition of grits. But we are seeing in this particular cross section that they are occurring not as horizontal beds, rather as dipping beds. So it means this area must have been uplifted, because now it is exposed, and this deposition was occurred in submerged conditions. So this must have been uplifted, and during or after upliftment the bed must have been got tilted like this. So here at the bottom we have shale. We don't have idea about the basement of the shale, so it is unconformable. Then we have conformable depositions of limestone and grit. So we can summarize that the shale was deposited unconformably over unknown basement, followed by the conformable deposition of limestone and grit. Then the area was uplifted and tilted during or after the upliftment and eroded to form the present day landscape. So in the next class we will be learning some another maps.